Okay. Hi, Apurv and Khalis. Can you say something? I need to check if the audio is fine.
Yeah, I can hear you.
Okay, perfect. Yeah, so let's start. Okay, so this is a Robotics and AI Meetup number 26, and the theme for July is actually robot manipulation. Just generally talking about different applications of robot manipulation. So today's session would be exploring robot manipulation in general, and in the subsequent session we'll take up one particular application of it and dig deeper into it and try to understand maybe one pipeline, and also maybe deconstruct a few existing products in the realm of robot manipulation. So today's session would be, after my introductory presentation, we'll have some brainstorming and discussion. It will be more discussion based today, and after that we'll fix a topic for next meetup, and then also do introductions and casual networking. And to just briefly also talk about what we are generally doing here is we are an active learning group of robotics and AI enthusiasts, and we are a volunteer driven community, and anyone is actually free to share their ideas, their projects, anything, and participate in these casual discussions that we have as well. So now we have structured our meetup such that we have a theme for each month. We have had multiple themes over the past several months. So we covered kitchen robots, cleaning robots, and autonomous drones just last month, and now we have robot manipulation. And the first session is every time the first session is about exploring and having a broad understanding of the theme, and then we slowly get more narrow, and towards the end of the month we actually cover one specific aspect in a lot of detail. So yeah, if you're interested in volunteering for a project at some point as well related to robot manipulation, just write to me or write in the meetup volunteer section or in the chat room, and we can fix your slot. And apart from that, also we have other roles. There is a news feed updater, there is a documentary moderator, research paper reading club moderator, ROS club moderator, and Discord manager. I'll not I'll not describe these things. I think they're pretty clear, and if you're interested in some of these roles, you can take up. A lot of people have taken newsfeed updater role and other roles as well. So I'll get back to you on how to plan. The main challenging roles would be, I think, research paper club moderator and ROS club moderator. Apart from that, I think most roles are manageable and easy. So let's start with today's theme now. So, so I'm also kind of now structuring the first sessions, because the first sessions are totally random, which is what how we want to keep it. But just adding a little bit of structure to it is we'll start immediately with brainstorming, and we'll do some mind mapping and collect thoughts on what robot manipulation is and what everyone thinks about it. And then after that we'll see some applications, and then after that we'll go on to products, and then we'll do these discussions where I share screen and we watch videos together, and have a more open-ended discussion. And anyone can participate regardless of age or experience, so this is very beginner friendly. So let's start now. So the theme for today is robot manipulation. Let's start with talking about like what you guys generally think of, just like on top of your head. What comes to your head when you think of robot manipulation? So you can start saying that. So maybe I can start first. Is robot manipulation, so kinematics and dynamics would be an important aspect of it. So this is one part of it.
trajectory planning.
Trajectory planning. Yeah, and it can be
Visual
anything. You can also talk about applications, whatever comes to your mind. Just it can be very random.
manufacturing, uh,
Man,
like building and
you
hardware
mean
general.
you mean application in manufacturing?
Yes,
Okay, so I
yes,
think one section we can make on,
applications. Yes,
yeah, applications, and then maybe, yeah, manufacturing, right? Manufacturing, and then kitchen. Also, we saw
yes,
kitchen.
yes.
So kitchen. I think assembly and everything would just come under
On the yes, manufacturing.
assembly. Drilling, all these kinds of operations. So. Uh, Yeah, so kitchen tasks, maybe we can just classify it as that, and it can be, it can be related to cooking, but it can also be dishwashing, like placing it in dishwasher. There's also research going on that. So dishwashing. So, and another thing could be actually, um, so apart from kitchen,
Medical robot.
medical, yeah, surgical, yeah, medical, and yeah, surgery would be one major part, and also like pick and place can be actually very general. It can be to, maybe let's just write in manufacturing. So pick and place or bin picking, I think, would be a better word. I don't know if I can undo it. No. Yeah, so bin picking would be one part of it, and then, yeah. So yeah, about other like subject aspects, maybe we can get back to the subjects now. So these are some applications, and of course, artificial intelligence. Maybe we can just have one broad category,
Yes,
and all these algorithms that we have.
computer vision we can add as another
Yeah.
one. No, actually, computer vision itself is another subtopic in robot manipulation. Like we have visual servoing in uh, robot manipulation. I think it should come as under a subtopic under robot manipulation, not directly under artificial intelligence.
But it's a subcategory of artificial intelligence essentially, right? Reinforcement learning, machine learning, computer vision, all these things are actually under AI. And yeah, I mean, even if we are using machine learning, that's, yeah, directly using that maybe directly applied to robot manipulation. But just to give a category of all of these things actually.
Okay, okay.
So with computer vision, yeah, I mean, we don't need to expand this too much, because computer vision, then there's plenty of topics. But yeah, visual servoing you mentioned.
Even for measuring parts in industries, uh, for the metrical purposes, we use machine vision using on robots.
You mean in applications measurement?
Measurement, yes.
Okay, so I guess in manufacturing we can just add this measurement. Okay. Just anything that comes to your mind. This doesn't have to be perfect. So visual servoing would be one thing. Then, yeah, calibrating cameras. Like now, this is very
Yes,
specific.
yes.
camera calibration, and feature extraction, because like if we are, let's say, drilling, then it has to identify the hole or something. So feature detection. Yeah, there can be a lot of things, slam and stuff. Yeah, let's not expand this too much.
Yes,
Just
yes, yes.
yeah.
Like reinforcement learning for bin picking.
Reinforcement learning, definitely very important one for this.
Minimize the energy consumption. We nowadays scientists are looking up forward for reinforcement learning.
Yeah, reinforcement learning, then imitation learning can also be
Yes,
there.
observational learning.
What's observation learning?
It's like it will observe the. It's like if a teleoperation,
Ah,
as you
okay.
have seen. Yes, yes.
So teleoperation would actually not be under AI, right? We can make a separate category, or what do you think?
It can come under computer vision actually. Like,
Okay.
yeah, it's
Uh,
a feature extraction technique, right?
because
We
with teleoperation, actually, someone would be, maybe there would be gloves on that person's hand, and that person
haptics and yes, yes, yes.
would have
Or
sensors and stuff, and that would be linked. So I'm not sure if that
it
is
can be
under
under
AI.
application. I don't know.
Yeah, okay. Anyway, we can just, I guess, write an application that makes more sense. Tele, teleoperation. Yeah, in manufacturing, we have seen, like in welding and stuff, right? I think there's some research paper there as well. So yeah, I guess here let's write teleoperation. Yeah, and trajectory planning, very important stuff. And maybe we can write with kinematics and dynamics, I guess, like
Forward in
forward and inverse kinematics. Yeah, forward kinematics, I guess in one category we can write, right? Inverse and forward kinematics, then these singularities and stuff. And we can actually
configuration space.
configuration space. Yeah. hmm and with
Okay, DH,
dynamics. Sorry.
uh, uh, okay, DH parameters can come into forward
DH
and inverse.
parameter. Yeah, that. Yeah.
Yeah,
We can still write it separately. DH parameters makes sense. Yeah. And for dynamics, any suggestions?
I don't know much about dynamics. I've not dwelled into dynamics yet.
Okay. Yeah. I think that would
I think
also. Uh,
Jacobian matrix is used to describe velocities.
Jacobi, I mean, that would again come under kinematics, so maybe a subcategory here. Jacobi. Actually, DH parameters would also be kind of in here, but yeah, it doesn't matter. So, Jacobians, for velocity, acceleration, all these fall under kinematics, right? So, for
Yes,
dynamics, I think it would be a control side. So, control, then, these model predictive controls and other kinds of
QR,
controllers. QR, sorry, Q,
LQR, a linear
LQR.
quadratic.
Yeah, okay, yeah, linear quadratic. Yeah, and then there can be other ones. So yeah, we've already filled this enough. So let's move to trajectory planning and stuff. Yeah, so with trajectory planning, we also have these A star search algorithms, right? A star search algorithms.
B star
Uh,
also.
Sorry,
B star.
E star,
Wait, is it V star? Sir?
East. Okay, I have not heard about that. You said V star.
No, no, no. I'm getting it wrong. No, no, it's A star only. There's one method which is more refined than A star algorithm. I forgot. Uh,
We can explore that. There's this then Dijkstra algorithm. Not sure if I'm pronouncing it correctly, but yeah, there's extra. Then there's these, we can write like ROS packages somewhere. This move it package is
yes,
used
yes.
as far as I remember. Uh, and for kinematics and dynamics, yeah, any ROS packages or something anyone wants to mention here can be like computer vision. We can write OpenCV, just general. Uh, and for slam there's these rtab map and stuff, just to name a few, g mapping and all. So it's like robot
Feature
manipulation.
detection, we can use YOLO algorithm.
Yeah,
It's feature extraction. Yeah.
feature extraction. Yeah, extraction and detection maybe we can just write in one category. Feature extraction. Yeah, okay, I would mention the sift surf and all these kinds of things to, yeah, not make it too crowded, right? This is with computer vision, with trajectory planning. We mentioned this move it package, and yeah, I think like for kinematics visualization and stuff is also very important. So maybe gazebo I'll write somewhere. And is there a bigger category that we are missing? So I guess like hardware side, right? That would also be for robot manipulation. It has to, the robot design also has to be such that it's lightweight. So maybe mechanical design is one category we can write,
Yes, yes.
and electronics as well, control part. There's a lot of different things. Mechanical design, then electronics. There's a lot of like, it's whole robotics, right? Electronics engineering, then control should actually be a separate category as well.
Yes.
Joint control and yeah, PID and stuff. So I think we
Control systems.
control systems, yeah. And yeah, I guess let's not expand everything too much, just maybe a couple of things we can add in each of these categories. So with mechanical design, FEM and stuff would be important. So FEM, yeah, light body weight design, then multi-body dynamics.
Yes.
Actually, like these are all interlinked, right? Kinematics and dynamics would also be kind of,
Yes.
yeah, multi
You did in
in,
MPD, yes.
yeah, multi-body dynamics. But just to like get an overall idea of how broad this thing can get,
And
actually.
very important toolbox, Peter Cox Robotics RVC.
Yeah, that's actually good. Yeah. Uh, so I guess it's mostly kinematics related, right? That toolbox.
Yeah, it has machine vision packages also.
Okay.
Yes, but yeah, it's predominantly used for this kinematics DH parameters.
Peter Cork robotics package. Yeah, anything else we can add with controls? I'll just add, I mean, I don't want to expand this too much because it's already getting too crowded. So this, let's say PID, of course, control we also have here. Then electronics like PCB design and stuff. Motor control, again, like everything is interlinked, so to say. So uh, yeah, here I guess we can just write
Sensors.
motors, yeah, sensors, sensors, and then of course control of these motors would also be in control systems category. Okay, let's not expand it too much. Maybe reinforcement learning, I can add some things. Yeah, these algorithms, q learning, actor critic, I guess. Yeah. With imitation learning, yeah, I won't expand on it too much. It's just actually collecting data from humans. Maybe someone is wearing a glove or something, and then that data is being used to learn. So yeah, this is like as you can see now, this thing can get really complicated. There's a lot of different aspects that about robot manipulation in general, but in essence it's actually what we'll cover in this month is mostly robot manipulator arms, and there's still a lot of things going on with this. Yeah, anything else anyone wants to add before we go to the next slide? Yeah, there's no space even, so okay. Yeah, so talking about applications, like there's tremendous utility of robot manipulation in real world. This drilling and stuff, all these chamfering drilling, all these maybe inserting a peg in a hole. So all these kinds of operations that we also wrote here, right? These manufacturing operations, measurement, teleoperation, all these kinds of things, and then this opening a door, which can also be in office areas, homes, and it can be in a variety of different applications. And then this assembly of wheel hubs, assembly, and then this pick place. This is like very wide utility in a variety of different industries. This can be done. Then this is dishwashing. Then there was these in kitchen robots. We covered one aspect of robot manipulation in a lot of detail, right? How computer vision pipelines can be used to actually cut vegetables and actually boil and cook and or do all these kinds of operations. And then here packaging. So there's actually a lot of applications that we can cover as well. Is there any other interesting application anyone wants to talk about? I think we covered broadly what would be interesting.
Camera robots
Sorry?
in movie making.
Movie making, yeah, yeah. Actually, that's pretty interesting. With cameras, like we see, the job of cameraman is actually very hard if you think about it. He has to hold the camera and move it, and there are these gadgets that are equipped with gyroscope and help stabilize the camera and stuff. But ultimately, the person has to handle the whole heavy equipment and stuff. So yeah, that's actually a very interesting application of robot manipulation. There maybe could be robot manipulator arms, or mobile robots equipped with these manipulators, and that would be interesting. Yeah. Okay, so now I guess we can start watching some interesting videos and have discussions.
Okay.
Yeah, and from this point on, it's like very open, casual discussion. So if you have any suggestions as well, if you know about some, if you came across anything, we can I'll share it and we can watch it together and discuss about it. Okay, let me try to stream, although for some reason like streaming doesn't work. Yeah, can you see the screen?
Yes. Yes.
Okay, so I hope audio would also be, yeah, you could hear it.
Uh,
Can you hear the audio? Okay. Yeah, so this is one example. I've just taken very small clips. So this robot manipulation, and for this I think it needs to have a sense of the object. It's a pretty heavy object that it's picking as well. This is a pretty old video actually, 2013. Yeah, so this is one. This door opening. This one probably most of us have already seen, right?
Yes.
So this one, like adding more challenges, and despite, I mean, opening a door is a challenge in itself, and like couple that with
Yes.
the difficulties that this guy is adding. Do you guys have some suggestions on like videos, articles, or anything related to manipulation?
Um, there
Actually,
was one
yeah,
Kuka Robots tennis. I think everyone must have watched it already. That table
yeah,
tennis.
yeah. Watched it. Tennis playing Kuka, but yeah, it would be, I think, interesting one. I think this part was where it was actually serving the ball. Here, we can have a look at it
That's very
close.
complicated. I mean, how did it plan in that way?
What do you
Plan
mean?
its motion itself. I mean, to serve in that particular way, right?
Yeah. I think it was. It must be like predefined.
Yes.
Uh, I think the ball is also kind of mounted here,
So
and
it
then
was
it
holding. Okay, it will leave it. Okay.
yeah, nobody, yeah. Otherwise it would be, yeah, it would be super challenging, right? If yeah, if someone maybe throws the ball from outside, and then it does, then it
Yeah,
has
definitely.
to track the ball as well.
Yeah, definitely.
And this one, I
It
think
was
they've,
mounted first. Okay, and then, but if you see how it serves, that also is very complicated actually.
yeah, let's see it again.
Does it have camera mounted on its arm or is it somewhere else?
Not sure. I'm not sure if this is shown in this video.
Yeah,
uh, and actually this video was more for, advertising, I guess.
advertising, definitely. But
Yeah, but yeah, I'm not sure. Let's see if there was some camera or something. Actually, if the ball is actually kept, on the robot itself, then it just has to, for serving, it has to do a series of uh, steps, like predetermined.
yes, yes.
But yeah, I think after the main playing part is where it needs camera.
Nowadays it can learn itself, like using imitation learning. Like one can uh, manipulate the arm in that sense, and it will do it the same many times till it achieves to replicate the task.
Yeah, I think imitation learning.
Or okay, there was one video where on imitation learning itself. I
Mhm.
forgot it was on Steve Brunton's channel. I forgot. Can you pull up the Steve Brunton reinforcement learning?
Okay.
I-
This.
yes, this one. Y- uh, yes, can you open this? In this video? He shows one video itself.
Okay. Reinforcement learning overview. Mathematics of
Welcome back.
reinforcement learning.
I think
Here.
examples. Yes. Yes.
Examples. Okay. This one.
A
Yes.
ball
Yes.
in a cup. This is a fun kids game. And so an expert human first off gives the robot like one example to show that it's possible. And then after imitation learning, the robot gets to, through trial and error. Notice that there's a white screen and the cup is blue and the ball is red. So it's using visual information from a camera. And after a few iterations, it's actually getting pretty close. I think this isn't so different from how a child would learn. You know, a kid's not going to learn this in 2 trials or 3 trials. It might take a few dozen times before it actually gets close and then learns how to catch the ball in the cup. After 45 trials, it's getting very close. It bounced right off. I don't know if it'll get it at 60. I think it barely misses. But it's getting very, very close after 60 to catching it in the cup. And finally, after 100 trials, the system has actually learned the rules of the game, the physics of how to get that ball in the cup. Very simple robotic example, but it's also pretty interesting. I mean, this video is not that recent, but very interesting to show that it is possible to learn a real physical system. This is another example I love. This is
So actually here, like the data was being collected by that person,
Yes. Yes.
and imitation learning. So I mean with the KUKA, the tennis playing one, it could actually be something similar. Maybe I mean we are just kind of guessing here, right? So
Yes.
it
Yes.
could be like a human playing, and then the movements of that, and that could be made after some conversions and transformations, could be fed to the robot. Or maybe it's just there's maybe it's just for advertising, and there's not much going on there.
Definitely.
It
Yes.
could be like with Boston Dynamics, a lot of things that they do, they are maybe hard coding stuff and doing multiple takes of it to capture the perfect one, I guess.
Obviously, even that dance, that New Year dance took a
Yeah,
lot
yeah.
of
More for
trials. Yes.
entertainment, yeah. And then there's another example here, I guess.
That is for
and again,
inverted pendulum.
Inverted pendulum,
they
yeah.
Yeah,
are
we
using
did this.
some combination of
You
trial.
showed us that OpenAI gym back in 2 to 3 months back. You showed when we were discussing about the reinforcement learning.
Yeah, exactly. Yeah, I think I think it was like 4 5 months back, probably, or something.
And error
Yeah.
and a physical model.
Yeah, so this, I guess, we've discussed using simpler example. Yeah. So let's see what other examples. So this DLR drilling and hammering one. This one was also a good example.
Anthropomorphic means?
Means like human form. So
Okay.
this video is a bit slow, so bear with me, but it's just 2 minutes in total.
No worries. Okay, it's
Yeah, this is more of a research thing. So yeah, so drilling in is one application, but this is more this is an anthropomorphic form, right? Human like form, and I guess this is more research specific, and probably in industries we don't have anything like this, right? So
yeah,
and also it needs to be very safe because this is a very sharp equipment that it's handling.
and it's not that cost effective.
Yeah. This is like more research specific thing that I think they've done. Um, and yeah, this one is another dart throwing. So there's like, I mean, only imagination is the only limit. There's like everything that we do with our hands, right? And we just try to use a robot to do that, and that's robot
Yeah.
manipulation. So there's these like landmarks there.
Oh,
Where is it hitting actually? Can you see?
yeah. No, you can see in the bottom. Uh, uh,
Ah, okay,
Bottom
yeah.
corner.
On the yeah. Ah, so all are all are at the center. Yeah.
How old is that?
I think 2012. So it's pretty old actually.
My God. Is
But
there any paper attached with it? Is it based on any
probably,
paper?
yeah, I think probably there would be because it's from TU Munich. Uh, Dart throwing with robot manipulator. We can Google search it. ICSTU Munich.
Okay, I will find it.
Humanoid robotic systems. Dart throwing. Yeah, I think on this website probably you'll find a research paper. So Institute for Cognitive Systems. Yeah, I think somewhere uh,
I can
in the
Google
research
Scholar.
section. Yeah. Yeah, yeah. I think on this website you will be able to find it, and we can also check like what other things they are doing. It's more robot can record human robot collaboration combining artificial skin signals and constraint based reactive control. Sensitive skin, so this is different direction. Active inference, body perception, and action for human
Perception
eye.
can be another major subtopic under robot manipulation.
Yeah, for sure. Action. So it's actually going to press this button, I guess. Okay, or maybe it was just going through this trajectory. Active inference, body.
Sensor. Sensor.
arm reaching. Yeah, okay. So it's going to track it and then reach it. That's nice.
Oh,
So tracking even after occlusions. So this is with camera. Actually, there's also multiple other sensors that can be used. Tactile sensors are also used, and actually, there's this research paper that we discussed here, right? So
making sense of.
yeah, so like to summarize, the view was actually just that. Combining, like using a multimodal sensor arrangement, it actually does better manipulation. So here it was for tasks like peg insertion, inserting car keys, and let me see if there was a conclusion or something at the end. Yeah, so it was making, yeah, I can just maybe search the paper, right? Yeah, so here, like if we use multimodal sensory, so tactile sensors and also vision, and then yeah, it can perform the task better. Humans use visual and tactile senses to infer task relevant informations and actions for contact rich tasks such as closing a bottle, and that's what they did here as well. So RGB, then force data, yeah, and robot state, so proprioception, and the whole idea is that like combining different kinds of data would actually be more useful for contact rich tasks. So this was one thing, and this one is again spot. I guess it's, you would have definitely seen this one, right? So so again, I think here it would, what would be interesting is, I'm not sure what object this is here that it's trying to pick. Yeah, but it's a deformable object, right? It changes its shape, and again, this one is also a deformable object that it's
I
picking.
guess sensing would be very crucial in the case of deformable objects because
Yeah, actually, my thesis is also in this direction, sensing deformable objects. I can also share a bit of that after this.
definitely, definitely.
So this is opening door. Okay. Oh, this is an interesting application. I didn't think about this. Planting.
their research is not open source, right? But definitely.
Sorry, you mean Boston Dynamics code is not open source?
The research, I think it's not open source, right?
Yeah, I'm not sure. I don't think so. This was one, and yeah, this deformable object manipulation. Actually, this is there's actually recently Google had updated something. So this is one, actually this is pretty close to my thesis here. Yeah, so given it uses deep reinforcement learning to actually now flatten this piece of cloth fully.
Oh,
Yeah.
how does it figure out that?
So it's taking, actually it's capturing images, and the images are states in reinforcement learning, right?
Okay,
So
okay.
images are states, and then in the image, based on the pixels, it selects pixels, and then those are transformed to actions, and then that action is made to
But
do
what
pick
is
and
it?
place.
What is its policy? I mean, how does it reward the agent?
So so the agent is yeah, so the reward function is actually like overlapping of this piece of cloth.
Okay,
So let's say this is one image that it will capture at any time step, right? And then this is the ideal image, and then overlapping of those images. So the more overlap that we have, the more reward that we get, and that's how it learns that yeah, it's going closer to the goal state. So so here, and in this case, it's actually trying to open this fully, and also the goal state would be again matching the image with this thing. So actually I can also explain this particular paper, because I've read this in one of the sessions maybe in this month. So yeah, it will match it, and with the cloth one. So let's say this is an intermediate position, right? So then image is captured, and then it will overlap it with the ideal image of fully flattened cloth, and maybe the overlap would be, let's say, 50% or something, and then it will do actions based on the policy, and then it will slowly learn to open it. But it's actually like, if we watch it, then it takes actions, but it's 30x, it's 30 times, so it would actually be very very slow. This
so
is a very complicated task to do. So it eventually flattens it fully. This is one thing, and with fabric manipulation, and actually with there is this Google deformable object manipulation. So Google also has good research in this area. Learning to manipulate deformable objects, I guess. Yeah, this one. So this is, I think, for different tasks. So this is actually like placing this third one is actually placing some object into a bag and then moving a bag there. So this is super complicated. So it's placing it inside this bag.
okay, now packing it.
Sorry.
Now it's packing it.
Yeah, it's packing it. It's packing it inside a bag, and here it's probably just moving it inside this area. Yeah, this thread kind of, and yeah, it uses different arrangement. I haven't read this article and or anything, but this is also interesting. Maybe I'll add it in the chat room if you are interested. I think you can read this later as well.
Definitely.
This one, and for robot manipulation, there's this book by MIT of robot manipulation, and they do have exercises. I just came across this, and I think this would be a very interesting way to learn, because there's like also exercises along with it. So like I think first one is just basic getting familiar with the robot, and then there's pick and place with kinematics, and then pose estimation, so also computer vision, and then bin picking. Also it has like a lot of things, so I highly recommend, and there's these Jupyter notebooks in all of these exercises. So this one is interesting. Yeah, and moving to deformable object manipulation again, so I think this would be interesting.
Did you ever waste a thought on how much cognitive effort goes into folding a towel? Probably not. As a human, you can easily recognize seams and wrinkles. But to robots, this task presents an extraordinary challenge. Let's take a look at a typical industrial laundry process where thousands of towels are handled each and every day. The dirty towels are loaded into a washing machine. Afterwards, the water is pressed out and the towels are moved to a dryer. Following this step, they're automatically delivered to a folding machine. This is where the process still depends on human labor. Now, the towels are picked up by a worker, smoothed down, and placed on a conveyor belt. From here on out, the towels are folded and finally delivered to a wrapping machine. To speed up this process, we provide a system capable of closing the gap to a fully automated industrial laundry. We have been working tirelessly on an intelligent handling system for textiles. To achieve this, we use the newest camera technology and highly sophisticated computer vision software. We combine them with deep learning methods and application-proven gripper systems. Our underlying principle is simple. We aim for a solution best suited for all applications of textile handling to deliver a truly astonishing result.
Yeah, so this is an actual industrial application. So for folding towels, they are actually feeding it to a folding machine, but all the other manipulation, moving it from bin, then flattening it and everything is being done by the robot itself. So yeah, so this is actually the startup where I'm doing my master's thesis currently. So yeah, this is pretty difficult task that they're doing there. And let's see, there's this dishwashing robot. This one is also.
The next set of robots that could have a huge impact in the home.
Has anyone seen this? Probably, I think this one is also very popular.
Oh, I'm not sure.
Okay.
Robots with hands that are able to move objects in the world more like what a human could do.
Let me tell you what we're looking at here. This is actually a factory robot. We've staged it in front of the kitchen sink and the dishwasher, but we're asking it to do an extremely hard task.
Let's think a little about what it takes to make a robot load the dishwasher. It needs to be able to recognize whether an object is a mug or a plate or silverware. or whether it's something to be discarded. It needs to understand the shape of that object, where it is in space, its orientation.
Voice is not
One
that
of the
audible.
key capabilities
It's not
of the
audible?
systems is using
It's
feedback
not that
in our
audible.
control.
Okay, let me see.
Algorithms.
Is it better now?
When we pick up the plate, we're constantly monitoring the forces we
Little bit.
expect
Okay,
to
maybe
see
because
at the
I'm
fingers,
not
at the
wearing
hand.
headphones. That
Yeah, actually, I'm trying to see see where Discord voice can be increased. So, just a minute.
it will increase your voice.
Sorry, I'm not sure if increasing my system voice, system volume does much, but yeah. How is it
Using
now?
cameras to align the
Yeah,
hand
it's
to the
better.
plate.
Okay, so it did help.
This makes the system much more robust. Someone comes along and closes the drawer on the robot, it's actually reasons enough to set the mug back down on the counter, open the drawer back up again, and finish the task. Traditionally, robotics researchers have used physical testing to design their algorithms, but that's just too slow. We've seen a dramatic increase in the performance of our system. One of the big reasons for that has been our increased capabilities in terms of simulation and testing. We want to be able to test our algorithms in software in the same way we test them in hardware. In simulation, we can run many more tests and more diverse tests than what we run in the real world. Every night, we generate random configurations of the sink with random objects, trying to find the corner cases, the rare events, the situations that we never thought to try in physical test.
Yeah, so this is a typical problem actually. When there's like objects in a cluttered way, and then you have to pick those and arrange those. So you have to know the object's orientation and position. So 6 degree of freedom grasping is needs to be done, or maybe even if it's of a lesser degree of freedom, then yeah, you need to identify at least the XY position and orientation properly. So this is one particular challenge, and this one we already saw, right? Molly Robotics with the kitchen one. So I'll just maybe go to the main part. So this is actually like making proper recipes, and it's probably using imitation learning to it actually collected data from different chefs while they were doing their preparing their dishes, and that's why it tries to give it a more realistic.
Uh, like with reference to the last video, in which
Yeah.
the collaborative robots, I think Universal Robots, their collaborative robots, I forgot what it's called. Nowadays, they are used in industries with workers. In Bajaj automation, nowadays workers, along with workers, is UR5, yes, cobots. It's pretty much dominated.
Yeah. Yeah, these like this is another I think, yeah, on Universal Robots official one we will get plenty of examples of robot manipulation. So this like machine tending and welding tasks using this. So
Our company is called Flywheel Supply. We're stationed in the Midwest and Northwest Iowa.
so it's actually, yeah, this is a cobot. It's actually operating with the person for welding.
Steam and boiler controls, valves, and gauges for both the industrial and some government type of applications. I saw a lot of labor involved that could be streamlined with a robot. The only way that made sense for us to put a robot on a machine tending application was to be able to do randomized bin picking. If an operator is to stand there and line the parts all up for a robot to pick them, it would defeat the entire purpose of using the robot to begin with. The cobot has to be able to pick a wide variety of part numbers. It's got to be able to pick up oily parts. It's got to be able to pick up randomized parts just laying them in. And then it's got to accurately place them so that the machine can process them in a timely and efficient manner. After the robot picks the part, it places them in the jaws, and then the machine indexes around to multiple stations to do multiple tasks. The tasks include drilling, chamfering, threading, a wide variety of applications. One of the biggest advantages to ActiNav is that we're able to do a bin pick with suction. We then verify suction in the logic of the program. Then we represent the part to the scanner if we don't have a part present at that point, or if the image sensor noticed the part is changing position at all and would make an unplaceable part, we then put the part in a region.
Bin picking is actually one of the major applications. So, like there is also jobs emerging in this sector a lot. Cobots, yeah, and yeah, again here is also probably similar application.
North American digital trade robot company. This digital experience will feature over 25 Universal Robots partner demos and 15 informative keynotes.
Yeah, this is also very like general virtual cobot expo. Okay, yeah. So yeah, anyone wants to share something as well? I've been sharing for a while, so.
What's more, painting, paint jobs was another application.
Yeah.
And it's pretty basic. And what else?
Actually, this different kind of painting, but this is also
Okay.
interesting. But yeah, in paint jobs, I think it's more in isolation, right? So not in a cobot way. Probably, I'm not sure. Actually, we can check now. Painting jobs, robots. Maybe I'll open this one in a separate tag. Yeah, so this is more in isolation generally with paint shops and stuff. Yeah, let's just have a look at this
Cloud
one.
Painter is a network of connected computers and robots that we're using in an attempt to replicate artistic creativity, and in doing so experiment with artificial intelligence. We try to have it make as many of its own creative decisions as possible, and it's getting pretty good at it. So here are several paintings made by Cloud Painter. You got several of my family, you got a couple reproductions, you got these abstract portraits right here, and those are the ones I'm going to go into detail about today. I'm going to walk you through the individual steps that went into creating the abstract images behind these portraits, and I'm going to let you consider those and decide for yourself just how creative Cloud Painter is. So anyways, similar to how human artists learn to paint, Cloud Painter got to this point with lots of practice. Over the past 10 years, it has painted more than 1,000 canvases with a combination of AI and human direction. But with its brushes, aesthetic decisions, the faces, way. A photo of origin to detect.
It's not. There's two different things, I guess. There's this Cloud Painter, and that's probably like just printing layer by layer and stuff. Cloud Painter.
After a couple hours of painting, the AI finishes with its best attempt at recreating the pastiche. At this point, the painting usually feels unfinished to me, so I take direction of the robot and touch it up a bit. Small touch-ups only, but these touch-ups are pretty revealing because they really show how much more.
Yeah, so manipulation is being done just for touching up the robot and trying to
Yeah.
reproduce it, I guess. Yeah. Mm-hmm. Okay. Okay, let's now talk about general. So, Khalis, I think let's start with your introduction.
Yeah. Um, um, Hello, you can hear me?
Yeah, we can hear you.
So, yeah, I'm new to this Discord. So, yeah, I'm a student, mechanical engineering student.
Mm-hmm.
So, yeah, I have interest in robotics and stuff. And yeah, the slide that you already showed that, yeah, I have learned it as a theory. So right now, like, oh, sorry, I think it's split out.
No, it's fine.
So, I want to know like how, but the problem is right now I don't know how to, what is the path I need to choose after my studies. That's the reason, like I'm
What are you studying currently?
mechanical engineering. Yeah,
Mechanic. Okay. And where are you from?
sorry.
Where are you from? Where are you located currently?
Currently I'm in Germany. I'm from Malaysia.
Ah, okay, okay. And are you doing bachelor's or master's? What exactly are you doing?
Master studies.
Master's, okay. And from where? Which university?
University Duisburg Essen.
Essen. Oh, nice. Because I'm also in Germany at RWTH Aachen University.
Yeah. Of course, yes. Of
Oh,
course, it's the one of the best universities.
uh,
I'm
so
pretty.
so you are you plan to go to robotics, or you are exploring, because mechanical engineering you can try different directions as well.
I'm really interested in robotics. That's why like my most of my subjects in mechanical, I choose like subjects that really related to robotics, and as well right now also like I'm learning about ROS and stuff, ROS and yeah, how to build in the KWS.
Oh, nice, nice, nice. Yeah.
So yeah, I hope like I can learn a lot in this Discord group.
Yeah, for sure, for sure. So we are doing these every week, Sunday 11 a.m. So CET timing would be, I think, same for you. So yeah, feel free to attend, and then next time we'll take one particular aspect of the things that we discussed, and we'll dig deeper, and we'll try to come up with a pipeline or something. You can also actually watch the meetup videos online on YouTube. I lost some of those videos, but most are already there, so you will get an idea of how we are proceeding with things.
Mhm.
Yeah.
And yeah, and at the beginning of this session that you say like you have some uh no, no, you have some projects that related to the manipulation. So is there any way that I can take part of it? So as you say.
You want to participate in some projects, right?
Yeah.
So actually there's this project section that we also have. Let me see, I rearranged the server a bit. Yeah, so here there's this exhibition section at the bottom, very bottom of it, and there's this project exhibition that people have shared different kinds of projects, so you can so this one is just to, I guess, have a look, because these are would be mostly completed projects. And then in accountability section you can find project accountability, and you can write here that okay, I'm interested in this kind of project, and I'm looking for some maybe partner to do with. Or you can also have a look at other projects that are already there and participate in that, direct contact them directly. So this is also what you can do. Apart from that, I guess we can we do probably plan to do some projects together at some point, but I guess after some months we'll do so. But yeah, just yeah, stay active on the server. I think uh, we'll find something for you.
Yeah, thank you very much. Because I try to be because like this semester can probably my the second last semester, so I will complete most probably next semester my studies. So I try to be active in this group.
Okay,
So yeah, I'm currently new, so that's why like, I want to know how this group is working.
okay. Have you finished all of your like courses and everything?
Yeah, I still have courses this semester, so
Okay,
like next
okay.
continue my thesis and then I will complete. So that's why like
Okay, okay, makes sense. Yeah, yeah, yeah.
I still want to know which path to do to take if I really interested in in doing the robotics stuff.
Okay. Yeah. What challenges do you generally face? Because you're taking some subjects, but ultimately for projects like you're probably trying to do it on your own, right? What challenges do you generally face?
Yeah, currently like for example like one of my projects related to the localizations, and
Hmm.
then one of it that I need to there's two options I can choose, which is Monte Carlo localization or Kalman filters, in order to make sure where's the robotic node where
Hmm.
they are. So it's really hard for me. So I need to do a lot of studies for it.
Yeah.
So
So
Okay. So mostly like theoretical, making decisions based on theoretical knowledge. You're trying to fill the gap, I guess.
yeah. And also the programming part for to implement the Kalman filters also is a bit hard for me.
Sorry. Once again.
The programming I'm using a C++.
Ah.
And
Okay. Hmm.
also the programming for implementation of Kalman filter, because I know the theory, and
Yeah.
also I have take a look at some in GitHub, some example of how people introduce a Kalman filter in their
Hmm.
localization. So yeah, I'm still learning, so I don't really have a deep knowledge about this, but yeah, I'm still learning. So
Actually, I can recommend you this resource, MATLAB Tech Talks with Brian Douglas. I think this has really good explanations, smaller 5-10 minute videos and really practical explanations. So I think for Kalman filter, sensor fusion, all these kinds of things, you can refer to this resource.
yeah, I
even
really
his
appreciate it.
his channel is very useful. Brian Douglas channel.
Yeah, yeah. His way of explaining is like so unique, and he explains it in simple terms, practical terms actually.
Hmm?
So
Yeah. Please share it to me.
yeah, so I've written the name in chat room, MATLAB Tech Talks. You can check it as well. Yeah, just just search it on YouTube. There's this channel. You'll find it easily. Okay. Moving to Apurv. Apurv, can you also introduce yourself again?
Uh, um, as you know, my name is Apoorv. I'm from India. I'm in my fourth year mechanical engineering. I just completed my third year, and that's why I was not so uh, present much. My presence was not much in the server the last 2 3 months, because I was going through my college exams and practical.
Ah, okay.
And
Mhm.
uh, and so I am doing my minors along with my major, which is mechanical engineering. My college offers minor courses which are related to uh, other than your branch. You can take up, like, suppose if you're doing major for mechanical, you can take business studies or
Hmm.
any other. So I took robotics. That's why I know some things about robotics. That's why, and I have the same problem as Khalis. I have a lot of theoretical knowledge, but still not lot. I have some theoretical knowledge, but I don't have hands-on experience much.
Yeah,
Yeah.
actually, I can totally relate. So I'll stop